Welcome back, everyone. It's time for another Universe Sandbox tutorial. By the way, Anton Petrov, I think is how you say his name, the popular Russian YouTuber, he used to do these all the time and kind of was my inspiration for doing this. But he's kind of just covering the news these days. But excuse me, I really miss his Universe Sandbox tutorials. Okay, so if you've seen the thumbnail, you know that we are covering Mercury today. But real quickly, I wanted to go over why there are five, outside of Earth, beyond Earth, there are five key places to the solar system. And some of you may have seen my video on this, but if those who don't, this is just going to be a real brief recap. There are five very special locations in the solar system that humans will colonize en masse. So the first one is in Jupiter's system. It's not really Jupiter itself, but Jupiter, being the home to the most resources in the solar system, is going to be a very important location. You've still got about 5% of the Earth's sunlight, so still enough to almost grow crops, but there's the magnetic field of Jupiter illustrated. But we are going to be talking about Callisto. Callisto is deep enough within that protective magnetic barrier to be protected from the sun's radiation while being outside of Jupiter's radiation belts. So kind of the best of both worlds. The radiation levels on Callisto are comparable to Earth. This and the surface of Titan are two of the lowest radiation levels you can find anywhere in the solar system. Io, the innermost moon of Jupiter, is the highest. So just to give you an idea of how dangerous those radiation belts are. So excuse me. So yeah, Callisto is our first location. Our second location is Ceres, which is the largest dwarf planet. I believe it's one of the smallest dwarf planets. It is the nearest dwarf planet to Earth. It's located between Mars and Jupiter. And its significance is it has a very high rotation, only 9 hours. It's very rich in volatiles and water ice, which make it ideal for agriculture. Then you have Mars. Mars, everybody, that's pretty self-explanatory. It's going to attract people by the thousands, if not the millions. It's the closest planet to Earth in similarity, not in distance, but in similarity it is. Earth has long held a fascination for a lot of people. Then you've got the moon. The moon obviously is very close to the Earth. It's going to be key to developing a fledgling space industry existence, really, beyond Earth. So once we can make it on the moon, we can make it anywhere in the solar system, literally. And then there's Mercury. Mercury is criminally overlooked, and I suspect it's going to be the most important planet beyond Earth a couple centuries from now, maybe 1 century from now. And the reason for that being, we'll get into the reasons for it. The reason it's criminally overlooked, though, right now is because, well, when people think of Mercury, they think of this scorching hot sunlit side as the planet slowly rotates, and the opposite side is freezing cold. So one side is too cold for humans to exist, and even with electricity and power, struggle to survive. And then, of course, the other side, the hot side, is nearly as hot as Venus, which is, again, almost impossible to survive. So bear with me, I'm trying to find the correct setting. But here, check this out. This is a temperature map of the planet, and it shows you that the side facing Mercury gets up to 800 and something degrees Fahrenheit. Extremely hot. Like over 200, I believe, Celsius. or right about 200 Celsius in those white regions. And then, of course, the dark blue, purple, is some of the coldest spots in the solar system. So because it has no atmosphere, it does not distribute the sun's heat and warmth evenly. So you have one freezing side and one very, very hot side. So any kind of civilization, people think, would have to stay somewhere in between the hot and the cold to survive. But this isn't true, because at the top of the world and at the bottom as well, you have very, very, very cold poles that occasionally see a little bit of sunlight, but the average temperature of the North Pole, well, sorry, not the average temperature, but the North Pole never gets hotter than 100 degrees below 0 Fahrenheit. And that's the pole. Now, the surrounding peaks and mountains, as soon as they see a little bit of sunlight, they get extremely hot. But what we can do is we can build a base here at the poles and regulate that incoming sunlight, reflect enough of it away that we get a nice, stable, warm temperature, but nothing that we can't survive. So we're kind of experimenting with that technology these days, where you've got very advanced glass where you could pass an electric current through it and it becomes more shaded or less shaded because the interior, the material inside the glass aligns with or against the sun's light. So we can do the same thing with a human habitat and keep year-round nice temperatures. So I'm going to get rid of the rest of the solar system because we're just going to focus on Mercury for a little bit. But of the 4 out of the 5 regions that I was talking about, Callisto, Ceres, Mars, the Moon, and Mercury, 4 of them have virtually no axial tilt. That is to say, they spin almost perfectly upright. I'm going to bring the Moon into this so you can see a nice little comparison of Mercury and the Moon. They're very, very similar in size, very close in size. So the Mercury is only slightly larger in radius, but when you measure its mass in moons, Earth moons, it's nearly 4.5 times the mass of our Moon. So, fun fact, Mercury is the second densest planet in the solar system, right behind the Earth. So what's going on with Mercury? Well, Mercury, like I said, is criminally overlooked because people don't understand how much better it is, let's put it that way, to live and operate at the poles. And the reason that is because of something called peaks of eternal light. Now, peaks of eternal light is an expression that was first coined way back in 1837 by 2 gentlemen named Beer and Madler. And they were discussing the mountains at the north and south poles of the Moon, and because they knew that the Moon had virtually no axial tilt, they speculated that the mountains at the very top of the and bottom of the Moon would be exposed to sunlight constantly. And as far as we know, there are no peaks of eternal light on the Moon. There are, however, 2 locations, both on Shackleton Crater, that receive about 97% sunlight, meaning that over the course of the year, 97% of the time, they are exposed to sunlight. So there are at least 2 places on the Moon that get very, very close. All right, now some good news. The ESA and JAXA, which is the European Space Agency and Japan Space Agency, have launched a mission quite a while back called Bepi Colombo, I believe is how you pronounce it. Bepi or Bepi Colombo, BEPICOLUMBO. And it's running a little behind schedule, but it's scheduled to arrive November of next year, 2026. And that's great. This will be, I think, the third mission to Mercury. Only the third. Magellan is the last one that I can remember. But there's 5 major mysteries to Mercury that hopefully the spacecraft will be able to solve. It's actually it's multiple pieces. When it reaches orbit, or when it reaches the location, I should say, it's not actually going to enter orbit. It's going to allow Mercury to sort of capture it. It's going to be in the vicinity, and then it's going to use its electric propulsion to maneuver itself into an orbit. But it's actually going to split up into 3 parts. One part is just pretty much the thrusters that got it there, and I believe the other 2 parts, one is an orbiter, and the final one is a package, a much smaller package, to study the electromagnetic field of Mercury. Yes, Mercury is the only terrestrial world besides Earth that has a magnetic field. It's a very weak one. It's only 1% the strength of Earth's, and of course, with its close proximity to the sun rather just overwhelms that completely, but it shouldn't have a magnetic field at all. So that's one of the mysteries that is hopefully the spacecraft is going to be able to solve, is why does Mercury have a magnetic field? We discussed Mercury's color. One of the mysteries, one of the 5 questions that Bepi Colombo will hopefully solve is, why is Mercury so dark? It shouldn't be that much darker than our moon, but it is. Perhaps more interesting is whether or not Mercury is geologically dead. This will be the 3rd thing that hopefully Bepi Colombo will solve. It would appear that there are parts of Mercury's surface that have collapsed, almost as if there were volatiles underneath the surface that had escaped Mercury, leaving room for the surface to literally fall in on itself. Perhaps the most important mystery to solve is, does Mercury actually have ice at its poles? Our radar data indicates that Mercury may have as much as 1,000 times as much ice as the moon does at its poles. But of course, until we actually can get there and measure it or see the ice for ourselves, it's still speculation. It's our best guess. And the final mystery, the 5th mystery, which I think is the most fascinating, is Mercury native to that part of the solar system? One of the reasons why many scientists believe that Mercury may come from another location originally is its potassium to thorium ratio. And real quick, I'm not going to get too scientific on this, but the terrestrial planets are very, very similar. Very, very similar. They have almost the same percentages of oxygen in their crust, etc., etc. But basically, and it's going to sound odd, like Mercury's eating too many bananas, Mercury has too much potassium. The potassium levels that Mercury has, I should say the potassium to thorium ratio is similar to a body that formed out at Mars's orbit. Okay, in summary, why do I think Mercury is going to be the most significant world outside of Earth in a century or 2? Well, it kind of has to be. If you use logic, it kind of has to be. I can't tell the future. You can't tell the future. We're going to be really caught off guard about what the next 100 years or 200 years will actually bring. But one thing's for certain. People, or whatever passes for people in the coming centuries, will need energy and will need matter. And honestly, there's no better location in the solar system than Mercury for both. But one of the biggest things that people overlook, and this was in my community poll, I asked, what is the average? What planet is closest to Earth on average, was the question. And many of you correctly answered Mercury. Mercury is the closest planet to every planet in the solar system. You could power an interstellar probe. You could push a small probe up to virtually light speed, or a good percentage of light speed, with enough solar energy. If we have, say, electric propulsion is the norm, you wouldn't have to carry your own fuel. You could have Mercury beam you all the energy you need, kind of like almost like a trolley system, where Mercury beams you the power you need for your spacecraft to travel the solar system. That's huge. That's huge. One of the things that you're going to be able to do is you're going to be able to beam that power, that heat and energy from the sun, from Mercury, out deeper into the solar system. Like you only need so much power and energy at Mercury, but what about Titan? Or what about even just Mars? Mars could buy all the heat and sunlight they need from Mercury. But yeah, why would you want to build giant mirrors in orbit around Mars when you could simply beam that sunlight and heat that you need directly down to your colony? You don't have to heat the whole planet. You could just heat 50, 100 miles around your colony. All right. Thank you for watching. I appreciate your time. Hopefully you enjoyed this video. Hopefully I did a good enough job explaining why Mercury is the future. And don't forget to leave a like, and please leave me some suggestions, because I love this stuff. This is exciting. I love talking about this stuff with y'all. And I love your ideas and suggestions. So keep them coming. Thank you. Bye-bye.